Hello, it's me again. Right, so this is the last bit of your 2.1, the effect of moment. When you try to estimate the size of your foundation when you have a moment coming in. Now, you must remember what the moment is. Moment is simply a load that is acting off-center. Recall that? When you have an off-center loading, it will cause an off-center distance, what we call eccentricity E. Alright? And when you have your load multiplied by that distance to the centroid, we have a moment. Simple as that. Okay? And just remember this, the simple equation. Moment is simply V times A, agree? Load multiplied by the distance towards the centroid. So if I want to know what is my V, what is the load, because in this situation, for example, if I'm being given the moment, I want to know what is P or what is V, that's a load. All I need to do is to take the moment divided by the E. Okay, now take a look at the diagram C here. When I have an eccentric load acting on my foundation, what you can see is that, yes, first and foremost, look at that the blue arrow coming down here. It is acting off center. I can see that, we can all see that very clearly, off the center, off the centroid, the center line, E there. And this is the original width of your foundation, B. But in order for me to have this load V passing through the centroid again, I will need to have a distance actually B prime. Can you see that? And mathematically, B prime plus 2E, twice your eccentricity, will give you the original B. Now, don't trust me on this, just go back after the class, just try to put in numbers to it. Right, please write down and try it out. Just sketch this in a scaled manner. Alright, use a ruler, draw it properly to scale. Say B is 4 meters, say E is 0.5 meters. Alright, I repeat, say your B is 2 meters and your E is 0.5 meters. Try to draw it to scale whether you get B prime and 2E accordingly. And you get B equals to B prime plus 2E. Just try it out, okay? Right. Now let's look at one calculated example on how we can, what is the effect of having a moment acting on your foundation. So again, this is actually example 2.20.3 is in your module as well. Right, again, first thing first, extract all the information that's in the question. So given my ultimate bearing capacity is 150 kN per meter square, it happens to be a square footing, so B prime times L prime is 2 by 2. Now I say, what is B prime and L prime? Now look back in the diagram here, look back in the figure you have here. B prime, L prime, so that is the original footing size. Alright, that's the footing size where the eccentric load is no longer eccentric, is in the center. Okay, and the moment given in one direction is 90, the other direction is 60. So we know that moment usually act in two directions. You have one direction, the other direction, depending on situation. So first thing first, I need to know what is my V, because I know M equals to VE, right? So I need to derive my V here. How do I derive my V? I'm being given the Q ultimate, so I know Q ultimate is simply taking the V divided by B prime L prime. That's the size of the original foundation. So I know my Q ultimate, I know my B prime L prime. Can I find my V? I can do that, right? It's algebra. 150 Q ultimate divided by the surface area B prime L prime, I get 600. Now, next bit is easy. All we need to do is to plug it into the equation. In one direction, say my B direction, my moment is 90 kilonewtons meter. So 90 divided by V, 600, I get 0.15. So in one direction, my eccentricity is actually 0.15. And to make the correction to my foundation, we know B prime is B minus 2E. Is that correct? Look at this. B prime is B, original B, minus your 2E. B is the dimension that you want. Alright? So you pop it in, B equals to 2 plus 2E. Now your foundation size, the B in the B direction, is 2.3 meters now. Do the same calculation for the second direction, L direction. Again, E equals to the moment of 60 divided by V, and you see that you get 0.1 meters. Pop it into the equation, you get your new L, that is 2.2. Can you see now? The new B times L is 2.3 times 2.2, larger than your original 2 by 2. So it makes sense, right? When you have a moment coming in, you want to bring the load back to the centroid of the foundation. So surely the foundation has got to be bigger in order to accommodate for the eccentricity. So that's what happens here. Got it? So true enough, with that, we have finished our lecture for today. That is for 2.1. Of course, this is far shorter than what we have got in the actual lecture room or the hall in campus, but we've got to stay home and stay safe. So this is what we have, the gist of it. Make sure you do your revision. Make sure you read through the chapter 2.1 in your module. All right. So take good care. Stay home. Stay safe. Bye bye.